Hey everybody, welcome back. Week 20. We're on February 8th, and we're on this idea of similar triangles. Just like on your phone, you take a photo, enlarge it, reduce it, but they stay in proportion. We don't distort. Okay? Well, how do we verify this? So last week we actually studied and practiced proportions. Okay? 3 to 4 is the same as 6 to 8. Okay? Well, how do we know that, right? Well, this was a scale factor of 2. Everything was times 2. Or, if you go backwards, divide by 2. All right? Okay. Now, there's ways to analyze this and study it based on angles, angle-angle relationship, the sides, side-side-side relationship, or side-angle-side relationship, as long as they're all in proportion. Okay, so each time we got a little bit of math to do. Okay, in proportion. So let's get started. The easiest one is the angle, angle, angle. Okay, so on your paper, just go ahead and draw 2 triangles that are exactly alike. Okay, whatever it is, doesn't matter. You pick. Okay, and I like to draw a 3, 4, 5. 3, 4, 5. And then I like to draw a bigger 3, 4, 5. 3, 4, 5. Now, when I do that, this angle is the same as this angle. 90 degree, 90 degree. And then this one, okay? Angle, angle, angle. All the angles are the same. If all the angles are the same, then we know the 2 triangles are similar. And similar is this little squiggle line, okay? So on your paper, go ahead and write some notes, and we'll call the little guy A, B, C, and we'll call the big guy. Now, you notice how they went A, B, C, D, E, F? In Mathia, they love to do A prime, B prime, C prime. See how we took the little guy and made it bigger, but all the angles stayed the same. So in this case, triangle A, B, C is similar to triangle A prime, B prime, C prime. All right? So go ahead and write that down. And then what we want to do is have you try one. So in your notes, this is the word for similar. The symbol for similar is that little squiggle, okay? And all the angles are the same. Now the reason they say the angle, angle is because if 2 angles are equal to 2 angles, then the third angles, subtract from 180, they have to be the same. So they're trying to save ink, okay? All right. Now, here's one. I want you to study it. Do I have enough information to say this is similar? Study and think. Is this similar? Okay? And I want you to think about, study, think, and use the idea of vertical angles. Okay? Use vertical angles here. See what you come up with. Okay? Now, we're going to draw this. It's just a bow tie. Okay? Now, they told us that is equal to that. So we have D and V. Now remember the idea of vertical angles. If I have 2 lines that intersect, I know that these angles are congruent. Okay, so vertical angles. Angle EWD is congruent to angle VWU. VWU. And that's called the vertical angle rule. Okay, vertical angles are congruent. All right, now let's just put numbers to it, just so that you understand that if this is 40 and this is 40, and let's just say this looks like 50. We're going to have to do more than that, huh? 40, about 80. Yeah, 40 and 80, okay? If this is 40 and that goes there, and that's 80 and that goes there, then these have to be equal, okay? Those have to be equal because we have what? 180 minus the 40 minus the 80. 180 minus 120, 60. Make that a 60, makes that a 60. Okay? All right. So now an angle, 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 all the angles are equal. They only told us one, but we have concepts in our head that says that we had more than one. All right. So now let's do the final step. WVU. WVU. Well, if I start at W and I go toward the 2, WDE. All right. Pause the video if you need to. Take a look at this, and we're going to head on. Okay? All right. The next most popular one and the easiest of all of them, in my opinion, is side, side, side. Okay? So give us a number. Somebody said 4. So let's do a multiple of 4. Okay? We're going to do a scale factor of 4. Scale factor equals 4. Okay? So let's just go. We do our famous 3, 4, 5. Similar by factor of 4. I'm just going to draw the exact same triangle, but I'm going to multiply by 4. Okay? So 12, 20, 16. Okay? If all the sides are in proportion, now here's the math piece. All the sides are in proportion. Okay? So 3 to 12. 20 to 5. 16 to 4. Notice how they all equal 4. They all equal 4. They all equal 4. This is the idea of proportion. If I can relate everything to a proportion, then I can calculate any side I need. Okay? All right. So, knowing that proportions are the key to success, you try this one. Okay? First line them up, then give them a try. Okay? Now I'm going to pause the video. I'd like you, I want you to pause the video, you try them, and then we'll get back together. Okay? All right, welcome back. So I'm going to go short to short. Short, medium, long. No, short, medium, long. Okay, short to short. Okay, 42 to 35. Medium 55, 66. And then the last one, 70 to 84. 42, so I went 42 to 35. I went this way. I wrote that upside down, didn't I? Yeah, so you always have to go the same direction. Okay, so let's go the same direction. 66, 55, and 84 to 70. Grab your calculator, do a little math. If we can show that each one is exactly the same, we win. Okay, so we got 1.2, 1.2, and 1.2. Now, the key to this is the proportion, because if I was missing a side, then I just set up the proportion. So let's, for fun, say I was missing the 84. I was missing the 84. Well, then I can just take these two equations. 66 becomes 55 as the missing side becomes 70. Okay? Then, as we practiced last week, cross multiply. 55x equals 66 times 70. Divide both sides by the 55, and yes, we get our missing length. Okay? So there's the math piece. All right? So that's in video part 1. Come back and we're going to finish this, because our most famous real world problem is side, angle, side. And I'm going to see if you can find a real world problem to use. See you in a minute.